The QUICKIE Iris changed the wheelchair industry by introducing rotation in space features never seen in a tilt wheelchair, offering unprecedented benefits. Its intelligence comes from the ability to adapt to changes in the individual and their needs. But first, let's discuss how rotation in space is different from tilt. As the name suggests, a rotation in space seating system simply rotates around a point in space versus tilting from a point on the chair. By doing this, a rotation in space chair has several key benefits. When properly set, the angle of the seat frame can be changed with the mere force of 2 fingers. Because the rider does not move horizontally during rotation, the wheelbase is significantly shorter than a traditional tilt wheelchair. This provides optimal weight distribution and superior maneuverability, even with seat angles as great as 60 degrees. And optimal weight distribution translates to greater chair stability. To fully realize these benefits, a rotation in space wheelchair must be properly configured so the chair's center of gravity aligns with the center of rotation. By answering 4 simple questions on the order form, the QUICKIE Iris is optimized from the factory. However, things change. Seating systems are replaced, backpacks are added, vent trays are added, seating angles are adjusted, riders' bodies change. Anytime the chair or even the rider changes, the center of gravity can shift, which can reduce the rotation in space benefits. This video will help you assess these changes and make adjustments to maximize the important benefits of rotation in space. The center of gravity is the system's center of weight, and the center of rotation is the point around which the seat frame rotates. Here is how you determine if the center of gravity is aligned with the center of rotation. When the center of gravity is aligned with the center of rotation, rotating or tilting the seat frame is effortless. When the center of gravity is in front of the center of rotation, there is an upward force on the push handle during rotation. When the center of gravity is behind the center of rotation, there will be a downward force during rotation. To ensure effortless rotation, 3 key areas of adjustment should be considered in order. 1. The center of rotation to center of gravity adjustment. 2. The rocker adjustment. 3. The rear wheel adjustment. If the center of gravity and center of rotation are misaligned, start by moving the seat frame and footrest supports to a location that aligns the individual's center of gravity with the seat frame's center of rotation. It is also important to re-establish the seat depth by adjusting the backrest. Next is the rocker adjustment. After the seat frame is adjusted, the overall seating position might be too far forward or too far rearward, depending on the direction the center of gravity was moved. If it is too far forward, the increased weight over the front casters will make the chair more difficult to maneuver. This position can also make the chair more front-tippy when traveling over obstacles. If the seat frame is too far rearward, the chair can become tippy when traveling up inclines. This position can also cause caster wheel-to-frame interference. Both positions can be adjusted by moving the entire rocker relative to the base frame to optimize maneuverability, stability, and front caster clearance. The final adjustment area is the rear wheel location. To increase stability, the rear wheels can be adjusted rearward. However, this should only be moved as much as necessary, as this may decrease maneuverability. In summary, the main benefit of the QUICKIE Iris is the incorporation of rotation in space technology, but its real intelligence is the ability to adjust its configuration to changing needs. To understand these adjustments in more detail, please contact tech support or your local account manager. The QUICKIE Iris, from invention to perfection.